Everybody's favorite, graphing. Let's read through this. Given a velocity time graph of an object, draw its position acceleration curves. Assume the object starts from the origin. So let's make sure we know what that means. Starts from the origin. That means my initial position is going to be 0. So I know that point right there. Label points at 0, 8, and 16 with their appropriate values. Show your calculations. Okay. So we'll label this one as 0 right there. No calculation needed, that was given. The key here is to go from velocity to position. We know delta S is the area. To go from velocity to acceleration, we know acceleration's the slope. Okay, so if we can find the slope of that point right there, we know its initial acceleration. And it's going to be the same everywhere up to there. So let's say the slope from 0 to 8 is rise over run. So our rise is 4 meters per second. Our run was 8 seconds. Which is 0.5 meters per second squared. So we have this value right here, 0.5, and that's constant up to that point. Okay. Area from 0 to 8 is simply this area right here. That's going to be 1/2 a triangle. And the height of 4 and a base of, let's go ahead and label that meters per second, and a base of 8 seconds. Okay, the units will be meters. Half of 4 is 2, times 8 is 16 meters. Alright, so we know up here at 8 seconds we're at 16. Okay. We know also that the slope of the position, so this at times 0, the slope of the position is the velocity. So this says I have a slope of 0 at this point. So I'm going to draw that in red. Okay, if this is a straight line, I know that this is going to be a parabola, and I know it's shaped like that because I know the slope down here is 0. Okay, halfway there. Let's keep on going. Okay, we go from 8 to 16 and we drop 4. So the slope from 8 to 16 is minus 4 meters per second over 8 seconds, or minus 0.5 meters per second squared. So we drop our acceleration down and it goes at a constant minus 0.5. Could connect these two or leave them like that. That's sort of undefined in that area given our graph here. Almost there. Alright, the area from 8 to 16 is this area right here. This is still above the curve, so it's still positive. And it's going to be that same set of values. Okay, so it's going to be 16 meters again. But we're already at 16, so we actually will end up here at 32. So that's delta S. Okay, that was a key thing a lot of people missed here. As far as shape goes, we know that the velocity right here is 0, so this slope has to be 0. So this is going to be curving back up and leveling off. Alright, so that one was a little tricky, but hopefully you can get the acceleration. You know how to get the change in position, 16 here, another 16 there, and relate the slopes as the velocity values at particular points on the position curve. So I'll stop there.